Welcome to Let's Make a Game Platformer, episode 30. In last episode, I added a way of modifying the prefab that is being created in the level or in any other place, and specifying the changes we want to apply to it. In this episode, I'll be using this feature, but what I'd like to focus now is sending signals. What I mean by signals is something that you're probably very familiar with in the platformers. Is, for example, when you switch some kind of lever, some doors open somewhere further or in the level or something like that. And to do that, we'll have an entity for the lever or a pressure plate, so that's something that's going to be on the floor, and when something steps on it, it will basically say, oh, by the way, this signal has been activated, and the door somewhere else will be saying, oh, the signal I'm interested in is being activated, I need to open. So we will have some kind of communication between two entities. So I'll start off by creating a new package in the core, where will be the logic package. I'll say signal. Package name will be signal. And we'll have, as I said, we'll have something that will be sending signal and something that will be receiving signal. So we have signal producer component. And I will have signal consumer component. And because we might have to have multiple levers and multiple different doors that each act on different lever, we have to somehow be able to distinguish which one is which. And I'll basically specify here that producer has channel. So basically it says this producer produces this signal on this channel, where we can name it whatever we want. And consumer will be saying, oh, by the way, I'm waiting for a signal on channel as well. Okay, so basically what will happen if someone activates either pressure plate or lever at the channel X, so this is going to be X, all the consumers that have this channel being defined here will receive an event saying their signal has been activated. So let me create the event now. Signal activated. I'm just going to extend an event, and it will have a channel. And when someone gets off the pressure plate or turns off the lever, we'll have signal deactivated event. Once again, we have a channel here. And a getter. Okay, so we have these two events, and now we have to have something that's going to be responsible for managing all those signals. So I'll create a signal system. I'm going to register profiles gameplay. So in here, what we need to do, because we'll have pressure plates, levers, and any other way like proximity detectors or whatever else you might think. So the sending of signals is going to be depending on the implementation. So we don't want to add stuff here. I want to have the separate system that basically detects that something is stepping on the pressure plate, some separate system for detecting lever being switched, proximity, and so on. So in here, instead, I will have a interface, signal manager, which will basically say signal activated, and signal deactivated. So whenever, for example, when I write a pressure plate system, it will, whenever someone steps on the pressure plate, I will have to call this method on the manager. And when someone is stepping off the signal plate, I will have to call the signal deactivated. The same for lever. In a lever system, we'll have to call these two methods. Okay, so now I have to make the signal system actually implement this interface. And I have to share it with the rest of the context. Okay, so in here we will have these two methods. Maybe instead I'll just get it here. So if this entity that has signal is activated, if this entity has the producer, we will have to read the channel it is connected to, and then we have to look through all the consumers and activate them. So let's look through all the consumers. I'll inject here a entity index manager. And in the initialize method, I will create the index on them. Signal consumer. And I'll iterate through all of them. And I'll have to activate it. However, if you can imagine that you can have two levers which open the same door. So when lever 1 was pushed, I should call the event. However, when the second one is going to be pushed, we should not be sending the event. So I have to make sure that I have to store in here, in the consumer, a value specifying that is it activated. So is active, or maybe is receiving signal. And setter for it, because I have to be able to set it. Okay, so in the system, I say if it's not receiving signal, then I have to set it to true. And I have to send an event, so I have to also save it, sorry. Signal consumer, save changes, and I have to send an event to it. So on the signal consumer, I have to send signal activated and the channel, because why not? Okay. So the same I have to do for the deactivating. So if it's not receiving, sorry, if it's not receiving, I have to make it receiving. And if it is receiving now, if it's receiving now, then I have to turn it off. But I have to turn it off only if there is no other producer sending signal on this same channel. So what I'll have here, I'll also add a entity index manager, signal producer component. And by the way, I have to check if consumer get channel equals channel. So only on this channel, and it's not receiving signal. And in here I'll have signal producers, and I have to iterate through all the signal producers. Maybe not here. So this is always going to be receiving signal because it was on, at least from this producer. However, we have to check here. So to go through all the other producers. And if signal producer signal producer get channel, and signal producer get component, signal producer component. Let me go through this. So first of all, I have to set on the producer that is no longer. So producer also has to store information whether it's producing or not. Is producing signal. Set producing signal. So set producing signal false. Producer save changes. Entity ref save changes. And then I go through all of them and check if at least one, if none of them produce system and produce signal on this channel. If signal producer gets channel equals channel, and signal producer is producing signal, true. So extract this. Is channel producing. So if no other producers produce on this channel, we'll have to turn off all consumers that have this. So first of all, we update this producer saying that it no longer produces the signal. And then we check whether any producer at this moment produces an event the signal on this channel, and if it does not, we have to update every consumer saying that it's no longer receiving a channel, no longer receiving the signal. However, only those consumers that have the same channel. And we send to them signal deactivated. Okay, and so what last thing here, I have to save it. The producer, I have to update it, it's saving signal. So once again, when some producer activates the signal, we have to first set that it produces it, and then for each consumer, if the consumer is on the same channel and is not receiving signal at the moment, we have to set that it's receiving signal and save it and send an event to it. And when a producer stops producing signal, we have to set it as no longer producing it. and check if no other producers send the same signal. Then we have to update every consumer that has this channel that is no longer receiving a signal. And consumer is receiving signal. Okay, so we got this part sorted. Now let's do pressure plate. Maybe hitbox overlap signal system, signal produce system. Register system. So first of all, we have to have in the update method, so receive event, check hitbox overlap, and game loop update. We'll go through all the so we have a new component for pressure plate, so hitbox overlap signal producer component, and we'll say that it's producing on the channel, or actually no, and that's just producing. And we'll have similarly like we had in the, where was it? In the physics. I'm sorry, in the hitbox we had. So similarly like in the platform system, where we are checking things that have a component platform movable, we'll have activate hitbox overlap signal producer component. So sort of flag component specifying that whenever this entity is overlapping with the pressure plate in this case, or something that has this other component, this one, it will be actually activating it. So let me first of all add this component to the player so I don't forget. We can also add it to other components like monsters, to other entities like monsters and stuff, but let's now go for this. And in here, we'll iterate through all the hitbox overlaps. So I'll have to inject the entity index manager. And we are interested in every entity that has a hitbox overlap signal producer. And the producer has to have the same stuff that we had in the platform movable, sorry, the platform component. So basically a hitbox for this one. So in the producer, we'll have the same for variables here, the same for fields, and in the system, sorry, in the producer system, we'll create the rectangle. So let's go also for location component. And we'll create a rectangle. Overlap. And it's gonna be location get x plus hitbox get translate x, location get y plus hitbox get translate y, and finally width and height. Okay, and now I want to inject the hitbox overlap manager, and I want to ask it find overlapping entities with this stuff, and the predicate is that entity ref has component activate hitbox this component. I have to different name entity. Okay, so this gives us and if we say if overlapping iterator has next, that means that something is at the moment on the pressure plate or on something that has this hitbox. Then we have to notify the signal manager that signal is activated on that entity, on the signal producer. Otherwise, we have to notify it that it is not producing. So the thing is that this is going to be called this is going to be called even if something stays on the plate. So we might have to make sure that we are only doing anything if the producer is not producing a signal in here. We are actually doing anything, and in here if producer is producing signal. Okay, so now we have this part, so all the stuff that's going to be listening on it. So now let's make a consumer package here, and I'll create a new class specifying move. Okay, how did we call it here before? Translate. Model translate on signal component. So we'll create something that will be basically whenever it receives this, whenever this entity that has this component receives a signal, so it has this signal activated, it receives the signal activated event, it will move to the defined position or by the defined value, and when it no longer is receiving a signal, it will move back to wherever it was before. So let's first define what we want to have here. So we want to specify distance x, it has to move, distance y, and distance z. And also I want to modify the time it takes for it to move, and also the type of interpolation. How do I call it here? Interpolation away. So like previously, whether it's going to be like linear, or it's going to speed up, or slow down, or bounce, or whatever else it does. Okay, so we have this here. Actually, this is going to be model translate component. Translate over time component. And we'll have a separate one, model translate on signal component. So we have to have two separate things. First of all, something that will, whenever signal is activated on it, will say, oh, I need to move now. And second one, that's going to be separate action, which basically says you can apply to a model and it will move. So the same way we had here the constant model translate component, we might have a model translate over time here. And here, consumer model translate on signal component. So I want to separate the whole movements over time from the way how it is activated because of signal, for example. So because I can later on use this for something else. So let me now create here all the same fields. But in this one, I'll have also a long get start time. So when the movement has started, because I have to be able to distinguish where in the process of moving it is. Okay, so I'll have a new class here. Translate on signal system. Gameplay profile. And it's going to receive an event. Move entity and signal activated. And we are interested only in those that have the model translate on signal component. And second event, move entity back when the signal is deactivated. Translate on the signal. Okay, so when this event is active, sent on this entity, we want to add the model translate over time component to it. However, if it has already one, we have to modify it. So let's do it. Let's entity ref. So you can imagine that when I step on the plane and step off of it, you will have these two sent like one after another, just one after another. So if the move is the door that I will be using it for opening and closing doors, when this entity is the door is closing or opening, I might suddenly tell it to do the opposite, so open and close. So I have to either modify the existing component. So I have to get model translate over modify existing one, or alternatively I have to add if it's not there. Translate over time. So let's assume that the translate over time is not there, because it's the easiest case. We have to apply to it. The value. I have to modify the values here. So I have to provide the setters for these values. Okay, and we need to have here base location as well. So, and we need also location. Okay, so we have all these values. So now we have to set distance x. So if we don't have it and we have to move away, it's very simple. We just translate on signal get distance x, translate over time sense distance y, distance c, I need the time manager here. So translate over time, set start time is time, and set move time is translate on signal get move time, and interpolation finally. Okay, and I have to create it. Create component, model translate over time. Set these. And that's it, I believe. However, if it's there already, so I have to move back. Let me figure out how I can do this. Okay, the way I'll do this is this translate over time component will have a boolean is reverse and setter. Okay, so in this signal system, I'll say that by default over time is reverse false, so it moves away. And in here I will do the same. however, yeah, okay, all the same, except the distance is gonna be not whatever it's set here, but we have to compare the current location. So you have to imagine that the door is mid. So let's say that activating it opens the door. So you can imagine that it's at the moment of it's closing at the moment, so it's going down, and it's like in the middle of being closed. So the distance you want to move from base location is actually 0. Or is it 0? No, it's location minus base location at x, because that's how much it has moved. That's how much is left to move it. Okay, that I think should work. And finally, I have to save the entity. Okay, now on being deactivated, so when I have to move the entity back, I'll do the following. Well, I'll do almost the same thing. So first of all, I'll check the time. And if it's moving, we'll say that it's reverse. And the same thing here. Okay. Now, so this should be fine for this component, for this system. And now I have to modify the translate system and go through all the things that have this component. So entity index manager, add index component, model translate over time, location, and base location. I'll iterate through all of them, and so we have these. Except the component is different. Move model translate over time. Okay. Progress is time minus translate get start time. This is how far we are along the process. And if then we have translate get move time. If progress is larger than move time, larger or equal than move time, then float a equals, maybe let's go the same order here. So if progress is less than 0, so we shouldn't start moving yet, then the IA is 0, as if progress is less than move time, so we are in the middle of the move, we'll put it there, else a equals 1, and I have to remove the component from the entity because it has finished moving already. So translate over time entity, remove components, model translate over time component. So clean up after it, and I have to save it. Or maybe save it afterwards, because we have to modify the locations anyway. Okay, and now we are in the middle of it, so we have to get interpolation. Util, get interpolation translate get interpolation, and A is interpolation apply 1f multiplied by progress divided by move time. And finally, locations is here. Okay, so we took everything into account except for the reverse. So what reverse means that we are moving actually in the other direction. So we're moving not from base location to the distance, but from the distance towards the base location. So how do I apply this here? Is it gonna be I think we should revert the A. So if translate is reverse, and A is 1 minus A. Okay, let's give this a try. So I'll have to create a couple of new prefabs here. First prefab will be the objects. I'll create a copy of this one saying pressure plate. I'll create a model for it. Pressure plate. And the pressure plate model, I created a very simple one here. Let's say all. It's gonna look horrible, but just bear with me. Pressure plate, and it's gonna be x is y 1, y is 0.1, z is 1, or maybe yeah. Okay, this is gonna be the sizes of it in the model pressure plate. There's no translation. We want to take the whole block. There is no collision, or maybe there will be collision. 1 and height 0.1, and we don't need this. We need base location, and the thing I need here is model translate. First of all, it has to be producing a signal, so it has to be signal producer. Component, and it's empty values, and it has to be signal producer, and this activate keyboards overlap on signal producer, yeah, this one, and doesn't need to have base location because this is the pressure plate, not the door. Okay, so we have these. So this is gonna use this model. It's gonna be producing collisions, so player will be get on the top of the pressure plate. We should probably specify which side it should produce collisions only. It should be top and bottom, I believe. Direction. Right. Okay, so we'll specify that the sides is top only, and this is the array, I believe. Yes, it's a list. Yeah. Okay, so top, because this is similar to the blocks we had for grass when we have down. Also, probably it's up, not down, not top. thing I should be doing here. So we have this one, and I'll create a new model, sorry, new prefab for door, signal door, which was the same model as the door that we used for opening and closing all the time. It will have collision, and it will have base location because we will be moving it, and it will have the component. So we don't need this part, and instead it will have, first of all, signal consumer component. So it will be listening for signal, and second of all, when it receives signal, it will have to schedule the movement. And the values it will have is these. So distance x is so the same as in the normal the cycle door. So 2. Distance x is 0, sorry. Distance y is 2. Move time, let's say 3 seconds. And interpolation linear. Okay, so when this door receives a signal, it will move up 2 blocks over 3 seconds in a linear fashion, and when it stops receiving a signal, it will move back to its base location, also in linear fashion over 3 seconds. Okay, so we've got that thing covered, and now I need to create a new level. So I'll copy the first one, because we just need to create a door on it. No, not second. It's gonna be 7. I'll make sure that the level sequence has only the 7th, because I want to test just the specific level. And I will add some object coordinates at -3, -1, 0. I will add the pressure plate. However, I'll be modifying it, so prefab name is pressure plate. However, I want to modify the signal producing component to specify the channel. So changes, I modify this one, specifying that the channel is let's call it signal. Then I will have at -2, -1, 0. I will have prefab name signal door with changes in the same way, specifying that signal consumer component. Channel signal. Okay, let me run this. Okay, so this class probably is missing the profile. Okay, signal manager. Did we not register gameplay signal system? Ah, it should be signal manager here, not system. It was saying that manager is not defined because it was not shared as a manager, it was snapshot as a system. Okay, so we have pressure plate. However, it doesn't do anything for some reason. Let's check the first one. This one. Because I've added the hitbox collision to it, it is no longer, it's not overlapping really. Okay, so let's run again. Also this one has to have the values defined, right? No, it's not this one. Okay, now I'm not jumping on top of it. It's this component, the pressure plate. Yes, I used incorrect. So player should have activate hitbox, so because it activates hitbox, and this one should have hitbox overlap. So this is the one that's checking for overlaps, and I should define the translate x, translate y is 0, and width and height. Width is 1. Where is it here? Width is 1 and height is, was it 0.1, I believe. Okay. Okay. Doors is opening, doors is closing. Okay, something is working. There's some weirdness on how it behaves. So I realized that I actually made it way too complicated than it has to be. So the component for the translation over time, I don't need a distance or stuff like that. All I need is just starting points from where I want this to move towards where I want it to move. So I'll modify it here. So get destination X, destination Y and Z. And I need also from it should move source X, source Y and source Z. And these start time, move time, interpolation. I don't need reverse because, well, I can specify this reverse of the source. Okay, and I need setters for this. So set source X, source Y, source Z, and the same for setters for destination. Okay, and in the translate on signal will be, so out here, if translate over time is null, I have to create it. And then I have to set all the stuff that I want to set on it. So source, so translate over time, set source X is going to be current location. Same for Y and Z. And destination is going to be when it's activated, it will go towards the destination. So the translate over time, set destination X is base location, get X plus translate on signal distance X. And the same for Y and Z. And start time and move time is going to be exactly what it was before. And interpolation as well. Okay, so this is it. And for moving up, for when the signal is turned off, you want to do exactly the same. So move from wherever it is at the moment, so from its location, and we're moving towards base location, so from where it started when it was first loaded. Okay, and now I also have to modify the system for translation because it doesn't have these places, these things anymore. So instead of base location and get X and so on, we'll do translate get source X plus 8 multiplied by translate destination X minus translate get source X. And the same for Y and Z. And I don't need the whole thing, the reverse thing, because it's already applied in the system I just modified. And that should be it. Okay. Okay, everything seems to be in order. And that's it for this episode. Make sure to like it and subscribe to my channel. You can also follow me on Twitter. A link is in the description. Thanks for watching. Bye.